Here we're asked to consider the function, and to start, we're going to put it in factored form. To do that, remember we got to use it's a cubic function, and so in that regard, I'm going to look at the possible rational roots, which are the factors of the constant, which are 1 or 2, over the factors of the leading coefficient, which is just 1. So I'm going to see which one of these I can divide out of this original function. So remember, I have a 0 for a placeholder here because there's no x squared. So I got 1, 0, -3, and -2. Bring it down, multiply it, add it, multiply it, add it, multiply it. That doesn't give me 0, so that doesn't work. Let's try -1. 1, 0, -3, -2. Bring it down, multiply it, add it, multiply it, add it, multiply it. Hey, we get a 0. So that means that part of my factored form is this, x squared minus x minus 2 from here. Now I'm diamond and boxing this part here, -2x squared, -x. So I'm just factoring this part here. So I got x squared, -2x and x, x, -2 and 1. So I get, for my factored form, f of x equals x plus 1 times x plus 1 times x minus 2. Or if I wanted to, I could write it as x plus 1 squared times x minus 2. For the second part, sketch the graph and describe the end behavior. So my graph here looks like it is obviously a cubic function, and it's going to bounce off of -1, and it's going to go through +2. And my y-intercept, when I plug in 0, I get 1 squared times -2, so I just get -2. So my graph should look something like that. My end behavior of this function as x goes towards -infinity, we're going down. As x goes towards +infinity, looks like we're going up towards +infinity. So that's my second one. And then use the graph to locate all the vertical asymptotes of the inverse. So I know that the inverse, or the reciprocal, I guess, of this is going to have asymptotes at my x-intercepts. So it's really going to be at x equals -1 and 1 at x equals +2.